Climate change is arguably the most complicated scientific issue humanity has ever investigated, and it requires the coordination of multiple disciplines in a way that has never been done before. And that's one of the things that makes all the more outrageous the idea that the science is settled, that there are no important uncertainties worth discussing, or that there can be no doubt about the policies we might try to address the problem. I try to simplify the scientific issues for a popular audience without compromising the complexity of the subject. The problem with the Vice President Gore's book and movie could be compared to the Da Vinci Code. It begins with some well-known and well-accepted facts and then goes off to make extreme, exaggerated, and fanciful claims that are not well-founded in science.
Well, one of the things that he says is that at the current CO2 levels, we will pass the threshold beyond dangerous consequences within 20 years. Does your science say something other than that?
Oh, absolutely. Look, there's lots of reasons to doubt that the models remember, we're trying to predict the future with computer models. We have a pretty bad track record at that. We're trying to model one of the most complicated phenomena science has ever studied, and there's lots of confounding literature that appears in the scientific journals almost every week that casts that kind of statement into serious doubt. Now, what I want to do is spend a little bit of time going through this schematic from the IPCC's last report. It never appears in any of the Time magazine articles on climate change or any other of the popular press accounts that you see. This is IPCC's account of what they call climate forcings. Forcing is the technical term for things that make temperature go up or that make it go down. The items that go up from the center line are positive forcings, or things that make the temperature go up. The things that are below the center line are negative forcings, or things that cool the Earth's temperature. Another thing to note about how this chart is organized is the solid bars are effects that they're quite confident in their estimate and magnitude. The thin lines are the possible estimates of the effect, but represent the range of uncertainty. And that's an important thing to keep in mind. So you see all the way over on the left is greenhouse gases. There you have a considerable amount of positive forcing effect, meaning an effect warming the planet. And then you get over to this whole group here on the right side of the chart that's aerosols and clouds. And there you see things going in both directions. There's one there, mineral dust, that they're not even sure if it's a positive or negative forcing. And then the thing I really want you to pay attention to is this axis along the bottom. That's called level of scientific understanding. And they've rated all along there. High, medium, medium, and then all the rest are low, very low, very low, very low, very low, very low, very low, and very low. Does this sound like scientific certainty to you when the official climate science body puts out a report like this? This same chart is going to appear in our next report a year from now. And they're going to upgrade a couple of these from very low to low. So there's been some progress, but not a lot. Now, I want to direct your attention to one in particular here, and it's the one all the way over here on the right that I'm circling that says solar. There's been a lot of thought for a while that climate change, or recent climate change, is the result of variations in the sun's sunspot activity or its luminosity and other aspects of solar cycles. Now, what you see here is it is a positive forcing, but a fairly modest one. And there are a number of scientists who say it should be larger than that, but this is what could be described as a consensus, that it's fairly low. Now, I'll just show you 3 articles from the scientific literature from this year, and you see why you can get whiplash following this issue. Here's one by several prominent climate scientists, including the 4th one on the list, Tom Widgley, that says, we don't think that variations in the sun have had any effect, or very little effect, on global temperatures since the 17th century. They do add, though, this at the end of their article. Additional climate forcing by changes in the sun's output cannot be ruled out. The suggested mechanisms, however, are too complex to evaluate meaningfully at present, which may be a fancy way of saying, well, you know, we really just don't know very well. Meanwhile, in geophysical research letters, 2 physicists from Duke University estimated that the sun, the last line on the chart here, the sun might have contributed approximately 50% of the observed global warming since 1900. So there's one group saying none or close to none. Here's another group saying 50%. And finally, an article from last May in Environmental Geology where 2 geologists who studied changes in the Earth's orbit as well as changes in solar radiation, say that they think that these changes are 4 to 5 orders of magnitude greater than human impacts on the Earth's climate. So there, you saw one group of scientists saying very little or none at all, another group saying half, another group saying the human component of this is very small compared to the sun. Well, that doesn't sound like consensus or settled science to me either. Now, the mystery deepens, and here, Nick's where I'm going to want the latter to be brought up. The mystery deepens when we ponder this chart. This is a data series that Vice President Gore also uses in his movie. What it is 450,000 years of carbon dioxide concentrations in the atmosphere on the top, methane concentrations in the middle, and global temperatures on the bottom. Now, if you saw the Vice President's movie, you'll remember that he gets on a cherry picker. And, he punches the button and very dramatically raises himself up to point at the top of the chart. I'm going to save energy and use a ladder. He goes way up high here and he points at these lines and saying, my goodness, look what's happening to the human emissions of carbon dioxide and methane. The point being they're way out of the range of what we observe historically. I will just add one little observation here. Methane concentrations in the atmosphere seem to have flattened. And in the last year, there have been a lot of very surprising findings about methane, such as a great deal more methane gets into the atmosphere from natural sources, including a story this week that the media loved about cows and livestock, maybe even more than industrial sources of methane. So what that means is that it's not entirely clear that human beings are responsible for more than half of this rise. But the real point of this is that by getting up on a cherry picker and pointing at these trends way up here, the Vice President and others who use this chart are engaged in a very interesting case of misdirection. Because one of the things they don't tell you, remember, it's 450,000 years of time we're seeing here. And these lines are not overlaid, but if they were and the time scale were expanded, you'd notice something quite anomalous about this. And that is that in almost every case, the temperature rise precedes the rise in greenhouse gases. In other words, the cause and effect is reversed. And beyond that, there is the question of why did we get those temperature spikes with almost metronomic regularity, by the way, in the first place? I mean, after all, there were no SUVs 350,000 years ago either. So what caused this? Well, we're back to the solar radiation hypothesis, I think, and changes in the Earth orbit and so forth. There's another item on this chart that's important to understand, and it's this one right here called the aerosol indirect effect. This has to do partly with clouds and the brightness of clouds. Partly it has to do with particulates, haze, dust, all kinds of things that get in the atmosphere that are reflective of radiation, some of them caused by humans, some of them caused by forest fires or just dust blowing off the ground. But what we're talking about is things like the cloud of haze you can see over the Atlantic Ocean in this satellite photo. There's a growing literature about the negative aerosol forcing. Science magazine in 2003 saying we really don't have much of a handle on this subject. Then more recently, in Science magazine, a group of scientists concluded that we think that aerosols in the atmosphere increase global cloud cover and correspond to a forcing that is larger than and of opposite sign to that of greenhouse gases. In other words, aerosols in the atmosphere might cancel out almost entirely the forcings we see from greenhouse gases. Or if the scientific community moves towards that consensus, what you're going to see is that you're going to get a bar of certainty that looks something like that in future climate modeling exercises. And that's going to leave us with a considerable mystery, because what you see is the positive and negative forcings coming close to canceling each other out, but we have seen these rising temperatures of the last century. This doesn't sound like consensus and settled science to me. One last thing on this issue about clouds. Clouds, water vapor, turn out to be the most important variable in the greenhouse effect. Now, clouds are evanescent. They come and go within hours or days. But there's constant churning of clouds in the atmosphere. The climate models are very poor at understanding cloud behavior. Here's a chart from Richard Lindzen at MIT. The solid line in the middle are the actual observations of cloud cover from 90 degrees north latitude to 90 degrees south. And then the thin lines are the predictions for cloud cover by different climate model runs. And you can see there's a little correspondence around the 0 latitude, the equator, but not very good out toward the extremes. And there's other reviews of climate models and cloud performance that do the same thing and that do no better than this particular run. Now let's change subjects a little bit. I mentioned about making extreme claims about what's happening. And so Vice President Gore and here Vanity Fair magazine talk about the possibility of 20 or 30-foot sea level rise, burying Manhattan. Now, of course, New York haters say, what's the downside here? Now, this is what you hear a lot. What does the IPCC actually say about sea level rise? Well, here's their rather complicated chart. This also refers to those temperature forecasts I showed you earlier, from 1.6 degrees on the low end to 5.8 degrees on the high end. And this is their predictions for global sea level rise. At the extreme, the highest estimate, they say we get 0.88 meters, less than 3 feet at the highest end of their temperature prediction. By the way, the early drafts circulating say that the IPCC is likely to cut their maximum sea level rise projection in half in their next report. The next one will have about 0.4 meters. And then you remember that video I showed earlier that Vice President Gore likes to show of a piece of ice the size of Rhode Island breaking off the Ross ice shelf. It's from this little peninsula up in Antarctica, and it sounds very dramatic to say a piece of ice the size of an American state. It would be less dramatic if you said a piece of ice the size of Orange County, California, which is roughly the same size as Rhode Island. And it's even less dramatic still if you back up and notice the small part of the entire Antarctic ice mass that we're talking about. What's actually going on in Antarctica, from a recent article in Science a year ago actually, is that while the minus signs show the ice that is declining down on the western side of Antarctica, plus signs show the ice masses that are growing in East Antarctica. Now, again, you can get whiplash trying to follow the science on this. I'll show you 3 articles, all published in the last year or so. First one says, snowfall-driven growth in East Antarctica mitigates recent sea level rise. That study concluded that actually it's lowering our sea level a little bit. Middle study says we can't really see any change in snowfall in Antarctica. And the bottom one says, from a review of satellite data, increasing mass loss in Antarctica. You can be forgiven for getting dizzy trying to follow the clashing science on this. Now, it's possible if you read these articles closely that they don't contradict each other as much or as directly as the headlines suggest. They're often looking at different data sets, different time periods, that's quite important, and different parts of the ice mass. This also becomes true in the case of Greenland. 2 articles from just a few months apart in Science magazine, one saying satellite confirms accelerated melting of the Greenland ice sheet, another study saying the ice sheet on the interior is growing. And then finally, another study out from a German and British researcher saying we can't see any serious amount of sea level rise from projected melting of ice sheets or glaciers in the next century. This one did get a little bit of press. So a group of Japanese scientists collated a lot of the different studies, tried to harmonize them, and what they concluded is Antarctic sea ice is going down. If you remember that false color image from earlier, there's quite a bit more warming happening there than anywhere. But Antarctic sea ice is going up. One thing that Vice President Gore does very well in his movie is explain that Arctic sea ice, because it's ice that's already in the ocean, if it melts, it doesn't actually raise the sea level because it's already in the water. And he shows ice cubes in a glass in an animation in his movie that's actually quite effective. The other one that comes up a lot that the Vice President uses is Mount Kilimanjaro in Kenya. We're told that, and this is probably true, that within another few decades, the mountain will be ice-free. And this is taken as a sign of global warming. Well, a lot of the scientists who look at this say, not so fast. This article from the International Journal of Climatology, as you can see, says, this is an overly simplistic view. And as they reviewed the data available on Mount Kilimanjaro, they found something interesting. Here's a chart that's from this article that shows ice masses on Mount Kilimanjaro and Mount Kenya and another snow-capped peak in East Africa. Mount Kilimanjaro is this middle time set here, and you see that you begin losing ice mass from the mountain way back in 1880, long before rise in greenhouse gases or change in temperatures. What this study concluded is that the loss of ice on Mount Kilimanjaro is much more correlated to changes in land use in the area, cutting down some of the forests, which had effects on some of the moisture convection around the mountain and made it drier on the top of the mountain. Well, enough of this. We can go on a long time about some of these, the confusing science and the contradictory science on ice masses, sea level rise. What most people want to know is, well, to the extent that there's a risk of climate change with significant damages at some point in the future, what ought we to do about the matter? Well, our first shot out of the box was the Kyoto Protocol. Kyoto, I think almost everyone agrees, even John Kerry in the last election campaign, is a dead letter. I'm quite convinced in the fullness of time we're going to come to regard the Kyoto Protocol as the climate policy equivalent of wage and price controls in the 1970s. This chart's from the latest report of the European Environment Agency on how the European nations are doing complying with their Kyoto targets. Their target is down here. That's what they're supposed to get by 2012 or so. They're on a path to end up there. And remember that Kyoto was supposed to be step one, and if step one is proving so difficult to do, what is step two going to be? And remember also that even if fully implemented by everybody, including the United States, the Kyoto Protocol would have done virtually nothing to lower temperature rise over the next century, even according to the climate scientists' own models. Well, lately there's been a lot of talk about what's known as stabilization wedges. I'll explain this idea. It comes from two economists at Princeton University, Robert Socolow and Stephen Pacala. And what they say is look, the Kyoto business got us off on the wrong foot. And it looked like a mountain too high to climb to reduce emissions from 1990 by the year 2010 or so. What we think is we ought to think about what future emissions might be on the globe. They think they're going to double in the next 50 years from 7 gigatons to 14 gigatons. And instead of just having a sort of a global carbon budget, let's divide the thing up like a pie and think of 7 wedges, each one of which, if they were implemented, would lower our emissions or keep them constant to about where they are today. And they include things like higher building efficiency standards and energy efficiency. One that interests me is doubling the fuel economy of the entire world's auto fleet and limiting people's driving to no more than 10,000 miles a year, or maybe even as little as 5,000 miles a year. Well, I'm not sure how realistic that is. I'm not even sure environmentalists would like this idea. I took this film a couple years ago of a League of Conservation Voters bumper sticker, "I vote to protect the environment," on the back of a Ford Explorer V8. It turns out even environmentalists might not go for this idea. But never mind that. You can divide any problem into wedges. World hunger, children poverty, and simple to conceptually solve any problem that way, especially if you don't attach cost estimates to it and weigh certain trade-offs. But nonetheless, I think this idea of the stabilization wedges is a more promising approach to thinking about the problem. Now here's the curious thing. Vice President Gore mentioned the stabilization wedges as the only real policy idea in his movie. But when it showed up in his movie, there were only 6 stabilization wedges. One of them went missing. This is actually from Scientific American, which did the same thing. Well, what do you suppose went missing? This is from Socolow and Pacala, and this has all 7 of their wedges. And one of their wedges is nuclear power. And Vice President Gore just skipped over that one and left it out entirely in his movie. Now, this seems to me a case of environmental correctness right out of the 1970s. And I think it's very hard to take people seriously who say that we're facing the worst crisis in the history of the planet, but rule out one proven existing technology that's nearly carbon-free. There are other things that you hear a lot about. One that Vice President Gore mentioned is carbon sequestration. And here's a diagram, actually, I think, from one of the Canadian energy bureaus, which shows that what we're doing is we're going to figure out ways to get carbon out of especially coal-fired power plants and store it underground in various other ways. Vice President Gore in his movie says, you're going to hear a lot more about this. The interesting thing is a lot of environmentalists are not very enthusiastic about this idea because they think it would be letting us off the hook from our evil ways of using fossil fuels. There's a monomania about we've got to wring fossil fuels out of our system. And if you think it's bad when you talk about sequestration, it really gets ferocious when you mention the idea of geoengineering. You remember a few minutes ago talking about particulates in the atmosphere, and aerosols and how that might have a cooling effect. Well, here's Tom Widgley, again, one of the leading climate scientists who's generally thought of as a believer in the more extreme scenarios of climate change, who says we ought to think about whether we can manipulate the aerosol content of the atmosphere to mitigate any potential temperature rise. Well, this idea sets off a firestorm when it's brought up. One climate economist says that would be like giving methadone to a heroin addict. Using fossil fuels is now considered the moral equivalent of a drug addiction. Even Rolling Stone magazine gets in on the act in its current issue, Can Dr. Evil Save the World?, with a fairly even-handed article saying, this sounds kind of wacky to us, but maybe we should take this idea more seriously. Well, two concluding thoughts. One is again, I mentioned earlier the demonization of people who dare to question the catastrophe consensus. In fact, there is confounding science published almost every week in the professional literature. I don't necessarily say contradictory, but confounding, meaning it confounds our grasp of the issue. And then finally, I'll leave you with this shot of the Earth and share with you the comments of one of the leading climate researchers in Britain. It's Mike Hume, who is the director of the Tyndall Center for Climate Change Research. They're one of the leading climate modeling outfits in Britain. A lot of scientists are quite intimidated these days to dissent from the party line. But last week, Mr. Hume said this to the BBC News. Climate change is a reality, and science confirms that human activities are heavily implicated in this change. But over the last few years, a new environmental phenomenon has been constructed in this country, the phenomenon of catastrophic climate change. It seems that mere climate change was not going to be bad enough, and so it must now be catastrophic to be worthy of attention. The increasing use of this pejorative term and its bedfellow qualifiers, chaotic, irreversible, rapid, has altered the public discourse around climate change. I have found myself increasingly chastised by climate change campaigners when my public statements and lectures on climate change have not satisfied their thirst for environmental drama and exaggerated rhetoric. It seems that it is we, the professional climate scientists, who are now the catastrophe skeptics. How the wheel turns. Why is it not just campaigners, but politicians and scientists too, who are openly confusing the language of fear, terror, and disaster with the observable physical reality of climate change, actively ignoring the careful hedging which surrounds science's predictions? To state that climate change will be catastrophic hides a cascade of value-laden assumptions which do not emerge from empirical or theoretical science. Well, I'll conclude with this thought. The catastrophic climate change emperor, unlike the emperor in the famous fable, may not be entirely naked, but he's not wearing very much. The point is, at every step, the greenhouse gas campaigners make the most pessimistic assumptions and forecasts, extrapolate any changes occurring in nature into harbingers of catastrophe, and they pound the table for an expansion of government control of resources. We are going to find that the problem of climate change is like other environmental challenges of the past generation, greatly exaggerated by the activists, and more susceptible to improvement than we think. The problem of climate change is going to look very different in the next generation.